the impossible mystery of white discoloration on some fiberglass pools. Hello, I am Sage Dazzle from Team Backyard Brands. Let's dive right in. The mysterious case of white coating on fiberglass pools represents one of the most challenging issues in modern pool maintenance. What makes this problem particularly insidious is that it defies conventional treatment methods and understanding of pool chemistry, requiring a complete rethinking of how we approach pool surface problems. The case typically begins when pool owners discover a ghostly white coating across their fiberglass pool surface. What makes this particularly baffling is that conventional cleaning methods, acid washes, scale removers, and other chemical treatments prove completely ineffective. The reason? This isn't your typical calcium carbonate scale that sits on the surface. Instead, it's become chemically bonded within the pool's gel coat structure itself, making it impossible to remove through traditional means. The root cause traces back to manufacturing defects in the gel coat application process. Proper gel coat curing requires three critical conditions: precise catalyst levels, 1.8% MEKP, controlled temperature environments, 70 to 75 degrees Fahrenheit, and adequate time for molecular cross-linking. When manufacturers cut corners or rush production, they create what amounts to a chemical time bomb in the pool's surface, similar to baking a cake with incorrect ingredients or temperature. It might look fine initially, but is fundamentally compromised. The science behind this issue is fascinating and complex. In properly cured gel coat, you should see complete cross-linking polymerization, resulting in a Barkol hardness reading between 40 and 50. However, compromised gel coat shows readings below 25 and develops 5 to 10% porosity, creating microscopic channels that become perfect sites for calcium compound formation. These microscopic surface defects create nanocurvature effects that enhance calcium compound formation at rates exponentially higher than on smooth surfaces. Salt chlorinator systems play a particularly significant role in accelerating this problem, with over 50% of these cases involving salt systems. These systems generate not just chlorine, but also sodium hydroxide as a byproduct, pushing pH levels above 7.8. At these elevated levels, calcium in the water forms calcium oxide, which can chemically bond with the compromised gel coat structure. This creates a fundamentally different issue than traditional scale. It's more akin to the material itself turning white from within. The diagnostic test is remarkably simple. Apply muriatic acid to the white area. Unlike normal calcium scale that fizzes on contact with acid, this bonded precipitant shows no reaction whatsoever. This lack of response confirms that the calcium oxide has formed covalent bonds within the polymer matrix itself, making it resistant to traditional chemical treatments. The salt system acceleration effect operates through multiple mechanisms. Beyond the pH elevation, the high chlorine levels combined with elevated pH create oxidizing conditions that penetrate microscopic cracks in poorly cured gel coat. Additionally, salt systems often create low Langelier saturation index conditions, making the water aggressive toward the gel coat surface, creating more pathways for chemical penetration and bonding in a vicious cycle. Prevention becomes crucial, especially for fiberglass pools with salt systems. The protocol includes maintaining pH strictly between 7.2 and 7.4, keeping calcium hardness below 120 parts per million, significantly lower than the 200 to 400 parts per million recommended for concrete pools, and targeting a slightly negative LSI between negative 0.1 and negative 0.3. For salt systems, operating at the lowest possible level and supplementing with UV sanitization helps reduce chlorine demand. For new pool installations, demanding proof of proper gel coat application becomes essential. This includes requesting Barkol hardness test results, minimum 40 to 50, and insisting on vinyl ester barrier coat application beneath the gel coat. This barrier creates an impermeable layer that prevents water from reaching the fiberglass substrate, eliminating the possibility of these chemical reactions entirely. Unfortunately, once this white precipitant has bonded, remediation options are limited and expensive. Professional gel coat refinishing, costing upwards of $18,000, involves completely removing and replacing the affected gel coat layer. Some companies offer vinyl ester barrier coating as an alternative to halt further deterioration, though it won't remove existing white precipitant. The industry implications are significant. Many manufacturers exclude cosmetic blemishes from their warranties, leaving pool owners to bear substantial restoration costs. This pattern extends beyond North America, with Australian pool owners reporting similar warranty claim rejections. It points to a broader quality control crisis in the fiberglass pool industry that's often masked by blaming water chemistry issues. For water care professionals, proper documentation becomes crucial when encountering suspected gel coat chalking. This includes collecting photos, water test results, acid test results, and barcol hardness measurements when possible. Reviewing installation dates and warranty terms helps prepare detailed reports for potential manufacturer claims. The prevention protocol for fiberglass pools requires strict attention to water chemistry management. This includes using chelating agents like SC1000 or quality stain and scale control products to sequester calcium and prevent precipitation. For pools with salt systems, installing an automated pH controller can be a worthwhile investment to maintain strict pH control. This case exemplifies how modern pool care often requires looking beyond traditional water chemistry solutions. Sometimes the most significant service isn't fixing what's broken, but identifying and documenting the true cause of the problem. While the white phantom might be impossible to remove once present, understanding its nature allows professionals to prevent future occurrences and protect their clients' investments. The investigation into this phenomenon continues to reveal new insights about fiberglass pool manufacturing and maintenance. As more pool professionals understand and document these cases, it creates increasing pressure on manufacturers to improve their production standards and warranty coverage, ultimately benefiting future pool owners through better quality control and more comprehensive warranty protection.